Yeah, are you there in the meeting now? Yes, yeah, is in the meeting. And yeah, is speaking also. But I cannot hear yeah. Rejoin, please. Yeah, is in the meeting. Now I think he will join and I will get notification. Okay, I will get. Yes. Now admit here. Assalamu alaikum. Why is it so? Lulu, you and me are only in the meeting. That's it.
Yes, sir.
I don't know why Yaya is not able to join me. Let me text him. I have texted him.
Okay.
And yes, are you preparing for AS or not?
Yes, I am. I'm preparing for AS.
Okay,
Yes, sir.
that's great. So, inshallah, you will be doing well.
Yes, sir. Hopefully.
Yep. Now I am joining and let's. Yes, I have joined, but why Yaya is not able to join? Sorry for this delay. Just let me mm, resolve this issue and then we will be starting the topic, inshallah.
Okay, sir. It's fine.
Okay.
Okay.
Here I was going to discuss about the topic of basically forces. I'm gonna share the notes to you. Assalamu alaikum. Do you hear me? Yeah. Hello, Mr. Yahya.
Sir,
Yes. Alhamdulillah. Now I can hear you, man.
sir, I can't hear you.
You can't hear me?
Wait 1 second.
No. Now is the signal clear?
Yes, yes. I think it's hardware issue. 1 second.
Okay. So do you people see my screen?
Yes, sir.
Lulu, were you present in the last class, na?
Yes, I was.
Yes. So we discussed this all about the field strength and all that stuff. And I told you how the field strength varies and how to figure out the graph. And as I told you that field strength depends upon the gravitational force. That is why that varies accordingly. Now there was one situation that what is actually the gravitational potential, Right after this, the topic is the gravitational potential. Okay, so ready?
Yes, sir.
Yes. Okay. So let's start with I have space. I have left this space for intentionally. I was actually wanted to solve a for question with you, but I will solve that in terms of worksheet later on. Now move on that we will be having the gravitational potential. This is a very important of gravitational field, and actually this topic deal by itself. This deals with gravitational potential. This deals with kinetic energy and all that stuff. So once we talk about gravitational potential, first of all, I must tell you that actually the gravitational potential is represented by unit per kg. Yani its is work done per unit mass, and its definitely unit is joules per kg. Okay, and it is a scalar quantity. Right. This is basically a profile picture of your gravitational potential. Now, moving on, if I have defined it, that gravitational potential is work done per unit mass. So this is not a mm, you know award scoring definition. So I have to define it in terms of the exam. So the exam definition is basically somehow a tricky 2 marks definition. So how can we consider that? Yes.
Sir, can you say that it's the work done per unit mass?
Yes, exactly. Very good. We can say that it is work done per unit. This is basically 2 marks question, that it is the work done per unit mass, or you can say the gravitational potential. I will write a G potential at any point is the work done to bring a unit mass from infinity to that point in the gravitational field. Okay, is it clear to you? So actually here some important points are there, that the work done to bring a unit mass from infinity to that point in the gravitation field is called the gravitational potential at that point, because it is a point dependent, position dependent quantity. So we simply say that yes, it depends upon the position. Okay, that is why once if we consider it that it is work done per unit mass. So for example, by definition, gravitational potential is equals to work done per unit mass. So if I say that work done is equals to force into distance divided by mass, so that force is basically gravitational force, and I can simply say that it is equals to minus g mass of the planet, mass of the object which is basically brought in the gravitational potential of the body, divided by r square, and this D and this M, they are basically outsourced values. So M and M is gone, and here you can say that D can be written in the form of R. That is why you will say that it is equals to minus GM divided by R. Okay, if you want to take one more step, I can consider it, but it will be cancelled out. So, is this clear to everyone? The gravitational potential has this formula, but this formula has a unique feature here, that is the gravitational potential is a negative quantity, right? What does it mean? That tells us about the properties of gravitational potential, right? The properties of gravitational potential. That is very important question. Most of the time this question is asked to you. Properties of gravitational potential. Actually, when we say that gravitational potential is a is negative, so what will be its maximum value? Where will it be negative, positive, etc., etc.? So first of all, it is maximum at infinity, right? It is maximum at infinity. Yani where the body is out of the gravitational field, or where the body is out of the gravitational pull, it is maximum there, right? Second thing, that its maximum value is zero. Very interesting. Its maximum value is zero. Yani gravitational potential maximum value is zero. Is it clear to you? The maximum value of the gravitational potential is zero. So zero means that if we will have the value of gravitational potential other than this, then what will happen? The gravitational potential will start decreasing, right? So as the object comes closer, as the object comes closer to the surface, closer to the surface of planet, what happens? It decreases. Are you getting my point? And when it decreases, any value below zero is negative. Are you getting it? Any value below zero is negative. That is why gravitational potential is a negative quantity. Now, next point is that as the work is done, at the mass, at the test mass, you can say, or at the smaller mass by the planet, so the mass loses its energy. When it loses its energy, actually its gravitation potential becomes negative. Okay? Its potential becomes negative. There are so many questions, yani, so many times asked that why explain why the gravitational potential is negative. So here, actually, what I explained, the significance of negative sign, right? Significance of, negative sign. Are you getting this point? Is this clear to everyone?
Yes, sir.
The significance of negative sign is mentioned here in all these slides. Now, there is one more interesting thing for the gravitational potential. If I want to draw the graph of the gravitational potential, because right after that, definitely there is the thing what we have to address, that is the graph of potential, gravitational potential. Usually, the graph of the gravitational potential is in negative quadrant, right? Let's say here is a planet, okay, and we must now that gravitational potential will negative, because at infinity it will be zero. So this is r, suppose, and r increases. Let's say it is r, it is 2r, it is 3r, it is 4r, it is 5r, it is 6r, and so on. In the same way, 1r, 2r, 3r, 4r, 5r, and so on. So as r increases, this is basically x in 10 power kilometers, right? 10 power n kilometers or meters. And the gravitational potential is maximum here, yani closer to zero. So it is zero. It is, let's say, negative 10. Let's say it is negative 20. Let's say it is negative 30. This is 5 into 10 raised power usually 8, 9 joules per kg and something like that. So what will happen? On either side of the planet, the gravitational potential is minimum at the surface. So as the object goes away, the gravitational potential decreases. But because the value is not getting or the distance is not getting are touching to zero, that is why you are not getting the value of gravitational potential zero. You I mean it is not being touched there. Are you getting my point?
Sir, may please just explain that again?
Sorry, can you ask me again?
May you please explain the graph again?
Okay, yes, yes, yes. I will explain it again. Don't worry. Yes.
Thank you.
Okay. For example, as I told you, that gravitational potential is a maximum at zero, and its value will decrease as the object is coming closer to the planet. So that is why I just consider that, let's say there is an object, and for that object the gravitational potential is minus 30 at its surface, minus 30 into 10 to the power 8, because okay, just make one-sided gravitational potential for you. Then I will be back and I will draw the other side. Okay, now let's say the gravitational potential is minus 30 at the surface. So as the object will increase its distance, the object is moving away. What will happen? The gravitational potential will increase, right? As the object is moving away from the planet surface, what will happen? The gravitational potential will be increasing. But the problem is it increases, but it reaches to zero. At infinity, it reaches to zero. Is it clear to you? Yani
Yes, sir.
as gravitational potential is equals to minus g m divided by r. So as r increases, gravitational potential increases again, but how? Negatively. So when it is increasing, it approaches to zero. Approaches to zero. You got it? Sorry, here it is zero. This r means from the center. Okay, so it is increasing. So yeah, it is increasing. So is this clear to you?
Yes, it is, sir. Thank you.
Welcome. Now, for two planets, if I say there are two planets, and for these two planets, I have this gravitational potential, and that gravitational potential is basically this is the this is, let's say, our planet, and for that planet, the gravitational potential is anywhere here. Its value is decreasing, and sorry, this is the question basically. What I'm going to draw, just a second. Oh, yes. And here the values will be very symmetrical. Symmetrical mean, let me draw these values symmetrically. Here at the surface the value is maximum, then it is decreasing, then it is decreasing, and then it is decreasing in this way. So this way, in the same way on the other side, it will be same here. It will be same 1 2 3 4, 1 2 3 4. It will be here, then it will be same as 1 2 3 4 5 6 7, 1 2 3 4 5 6 7 here. So it symmetrically decreases on both sides. Are you getting my point? So basically we consider that this is called a potential well. What do we call it? We call it a potential well. Okay. Yeah, is it clear? Potential well. This is basically a
Yes,
well.
sir.
Well mean, if there is an object moving towards this planet, and if it is trapped in its gravity, its potential will be decreasing, decreasing, decreasing. And apparently, what do we say? That now that object has this potential. So if it wants to escape from the surface of this planet, or from the gravity of this planet, that object has to gain a lot of gravitational, a lot of kinetic energy. So that is why if an object is coming closer to the planet, then it will be having, or it will fall in the gravitational well. Basically, I'm just, yani, hypothetically, I'm going to draw this diagram here, that that ball is now trapped here. So if that ball or that object will have that much mass, this will be able to escape from this potential well. It will go out. Are you getting this point now?
Yes, sir.
Red one is actually the graph, and black one is just hypothetical imagination of the coming out of the gravitational well, coming out of the gravitational well. So you can simply say that this is called gravitational well. Okay. You know, there is a science developed on the gravity, which is called Einstein's gravity, not the Newtonian gravity, that was based on a gravitational net, something like this. Did you ever hear about that?
No, sir.
Yes, you had. Basically, this is a gravitational net, or a net. This all universe is, or the gravity is considered as this way. So in this net, if you are going to place a heavy ball, then what will happen? That heavy ball will make this net to be pulled down a lot, and that is why this net will be now having uh, basically a deeper well in this way. Are you getting this point? So due to that, these all, yani, I am not going to draw it basically, but if you consider this, that all these lines would become tilted, then these all dark lines, black lines, now they will be basically tilted, and there will be a steep produced here. Steep will be produced here. So whenever there will be a ball coming closer to that, let me open it from the Google. Just a second. Google helps us out in so many places, so I hope that it will help me here as well. Yeah, this is that point. This is what I wanted to tell you. Right? Did you notice? Is my screen visible to you?
Yes, it is.
Yes. So basically, I will be back on my notes from here. This, instead of this all, it was quite easy to erase this all. Yes. Now that gravitational well will be well defined for you. Let's say I'm pasting it here. Yes. Did you notice that the bigger planet, this object has very deep gravitational well? Yani, the net shell is now changed a lot. Now I will be having another diagram for you. That diagram will be basically, it explains more about the gravitational pull or this net shell. Let's say this is the diagram. I hope that this will be more clarifying to you. So when the objects are coming closer to this net shell, what does happen to these? Yes. Yeah. Did you see this? It was very interesting thing that, for example, an object is producing a net, and that this object, let's say this is the object, or let me get some more. Yeah, this is fine. Yes. If you notice this, this is basically the net. They have explained this. It is just nothing but just a model, and that model shows that yes, what will happen to the object's gravity if an object is having very large gravitational. This is a quantum concept of your planet or gravity. Then gravity is still a myth. We are unable to find out the gravity. That is why this is a concept which is being shown to you, that yes, every object has or every planet has its gravitational well around it, or it makes a gravitational well, and that well depends upon the mass of the object. Just check this one out. If there is a big sphere, what will happen? It will create a big well or not? Actually, this is the gravitational line, and this is that potential well. Are you getting my point? This is
Yes,
that
sir.
potential. So that is why, if that shell will be deeper enough, then what will be problem? The problem will be if a ball is just here, if a ball is just here, or if any object is just here, it will be captured by this planet, right? And its shell is, its gravitational value is not that much. So once a ball reaching to its surface, it will be captured by this. But if the ball has more kinetic energy, it will leave it. But for this potential well, the ball needs lot of potential, lot of energy to leave. So this all is very interesting topic actually. But once I just teach it for a crash course, I do not go into that much detail. So here, did you see that what happened? This gravitational well is shallower well, but this gravitational well is very deep well. That is why this well is called the black hole well, because there is a strong gravity. So that is why we can say that if an object is dropped in this well, it will not be possible to get it out. That is what I was going to explain to you. Is this clear?
Yes, sir.
Okay. Now, moving on, I will be talking about gravitational potential energy, right? Gravitational potential energy. The gravitational potential energy is that energy which is basically occupied by the body when it is moving from infinity to a point in the gravitational field. So that is GPE, and that is equals to, either you can say, there are some different equations for that. This is basically the work done on any mass to bring it from infinity to that point in the gravitational field, right? It is for any substance or any mass, you can say, not point mass. So I can say the work done to bring any mass from infinity to a point in gravitational field, right? That is called your gravitational potential energy. And this gravitational potential energy is because work done. That is why I can simply say it is simply F into D. So that is why it will be negative G m small m divided by r square into D. And in your exam derivation, you can simply write that D can be written in the form of r. That is why this is negative G m m divided by r. So there is a difference between gravitational potential, gravitational field strength, and gravitational potential energy. That they are, gravitational potential energy is basically GMM divided by R. Yes, this is one of the formula of the gravitational potential energy. But if you see that the gravitational potential energy is also equals to minus Gm divided by R into M. So can I say that this negative Gm divided by R was basically equals to what? Gravitational potential? Was it Lulu or not?
It is.
So my gravitational potential energy is phi times m. This is the second formula you have to recall from gravitational potential energy. The third equation that I am going to derive, that your GPE is equals to minus Gm divided by R into M. But here you will simply say that as gravitational field strength is minus G M M divided by R square, then sorry, Gm divided by R square. So this M is technically not of this formula. Okay. So if I just consider that from here, from this equation, G into R, that is equals to negative G M divided by 1 R here. So what do you think? Can I say? Actually, what did I do? I just did minus G M divided by R into R. This is R square now.
Yes, sir.
So I just used 1 R here. I just took 1 R with me, and I just use the other R with this G. Okay, you got this point?
Yes, sir.
So it will be minus G M divided by R will be equals to G times R. So it means this value is basically equal to GR now. So I can just come back to this point that yes, if I have that GPE is equals to minus gm divided by r is equal to g times r into m, where r is written in the form of h. So that is why your GPE is equals to mgh. So these are the three equations for gravitational potential energy, and we have to consider these three equations. They are very important. So gravitational potential energy is the function of gravitational potential actually. So wherever you have to calculate the gravitational potential, its behavior, its variation, everything is same. So let's say this is r. Oh, sorry. Let's say this is r. This is 2r. This is 3r. This is 4r, and so on. And suppose the gravitational potential energy is here, GPE is here into joules. So let's say gravitational potential energy is something like this. So it would be decreasing by inverse law like this. Okay? So it decreases same like gravitational potential. So wherever you are going to calculate gravitational potential energy, simply do nothing but GPE is equals to m times phi. So for example, if I want to find the gravitational potential over this point, at this point, gravitational potential can be calculated simply by multiplying the value of gravitational potential with mass. So all these questions which are asked to you are basically the questions from, for example, in one of the past paper questions, there is a there is a graph of gravitational potential and gravitational potential energy. I will just explain it, and then I will be shifting to the other class. Okay, let's say this was a question here. Yeah, this is, let's say, a question. So actually this graph is the graph of gravitational potential, right? This graph is a gravitational potential of a unit mass, which is, oh, sorry, a point mass, which is moving from the surface of planet A to the surface of planet B. Are you getting my point? So here the value of gravitational potential is, let's say, 1 2 3 4 5 6 7 8. So let's say it is minus negative 8. So the value of the gravitational potential is into 10 raised power 8 joules per kg, and this distance is, let's say, 1 into 10 raised power 12 kilometers, and now it is moving 1 2 3 4 5 6 7 8 9 10 11 12 13. So let's say this is your 13 into 10 raised power 12 kilometer. Now if I say that an object of mass, or there is an object, and that object is traveling from the surface of planet A to the surface of planet B, right, in this way. Yeah, are you getting this point? So in between, I have taken different snapshots. So what will happen to this mass? This mass has a potential, almost minimum potential anywhere here. Is it? Now, consider the points. Actually, this is very interesting question. At this point, the question is, let's say, what is the potential here? Minus 1. And what is the potential here? Back. It is minus 876. It is minus 6 into 10 raised power 8. So if I ask you a question, let's say this is point A, this is your point B, and this is your point C. Let's mark it point C. So what is the behavior of change in gravitational potential energy from A to B? Yes, Lulu, can you tell me?
Um, I think it would be
Increases,
um,
right? And gravitational potential energy from B to C decreases. Did you see the graph? Basically, graph is obvious that the object is moving away, so its gravitational potential increases. So GPE increases, but when the object is coming back to the other planet, its GPE decreases. Okay, now if it is increase and increase in GPE, so loss in GPE equals to basically gain in kinetic energy. So I can simplify this variant as well, that now if gravitational potential energy from A to B increases, then change in kinetic energy between A and B decreases. And again, change in kinetic energy between B and C increases again. So where is the minimum speed then? These all are basically the things which are asked to you in your past paper question, right? So you can calculate this by m into phi at point B minus phi at point A. Got it? And this can be calculated as m into phi at point C minus phi at point B. Are you getting my point?
yes, sir.
Okay, then what else is there that you can find the gravitational potential energy, the minimum speed of small m, yani this object is between where? Here, where the potential is maximum. And what is this? 1, 2, 3, 4, 5, and 6. Between 5 and 6 into 10 raised power 12 kilometer. Are you getting my point? This is a past paper question. Is between 5 to 6 into 10 raised power 12 kilometer away from planet A. Okay, is it clear to everyone?
Yes, it is, sir.
Yes, so we will be doing this all inshallah in the next lesson as well. That yes, what is being shown here, this entire diagram, you can take a screenshot of this. That is why I have just considered that all in one diagram.
Okay, sir.
Hopefully, it will help you out. Right?
Okay, sir. Thank you, sir. So,
Okay.
if that question were to come in the exam, this is how we should answer it.
Yes, I will show you the past paper question also. For example, in next class we will be doing the question. Actually, now my one set of question is completed. Yani I can I'm able to solve gravitational force question. Okay, then gravitational potential energy question, gravitational potential questions, and all that stuff, gravitational field strength. So these all areas are now covered. Okay, one more thing I
Okay,
would
sir.
just, because the topic is about to end, so next time I will be not talking about gravitational potential energy in my next topic. So in this topic, let's find one more way to find the change in gravitational potential energy. This was one of the way, that if you have the graph, but the other way, the change is taken out from formula. That formula is basically, if you now delta GPE is equals to minus G M M divided by R A minus, this is basically the formula of gravitational potential energy with negative sign. This is the middle negative is basically for the change, and this is minus G M M divided by R B bracket. Now from this all you will get G M M outside, and it will be 1 upon R B minus, oh sorry, just a change, because always change is always final minus initial, right? Final minus initial, right? So that is why I can simply say that change in GPE, delta GPE is equals to GPE at point B minus GPE at point A. So it is 1 upon R A minus 1 upon R B. So whenever you are having the formula or whenever you are having the values, so don't use the other way around. Just follow this method. Okay?
Yes, sir.
Yes. See you then.
Thank you, sir.
Welcome. Yeah, yeah. Are you also there? In the entire class, you were just
Yes,
uh,
sir.
listener, silent listener.
No, sir. I'm here.
No. Amin, you were saying Amin?
No, sir. I'm here. I'm present.
Okay, okay, okay. Okay, see you then.